Welcome to the second module where we are going to discuss about the circuits using the negative feedback amplifiers. And these are the few things which we discussed in the last module, and I think we end up with this merits and demerits where we are able to list the merits, and the only demerit is less gain or reduction in gain. And there are the two illustrative circuits where we could get some important information about the negative feedback. The first thing is RC coupled amplifier. And what do you mean by RC? R in the sense resistance and capacitance are used to couple the different stages in the amplifiers. This is a single stage amplifier. We can increase the stages just by coupling with the help of R and C. Here the transistor is connected in the common emitter mode, and the effective input signal is given between the base of your transistor and the emitter of the transistor. And Vs is the voltage source which helps to give the input voltage to the transistor. What happens if this bypass capacitor is removed? When this is removed and then Vs increases, the emitter base junction becomes more forward biased, the collector current increases, the emitter current also increases, which develops an voltage called IE times RE. Now this effective input voltage is not same as Vs, and this effective input voltage may not be in phase with Vs. So this is an exact example of negative feedback. So the feedback is also negative and the gain is too low, and on the other side the advantage of negative feedback can be achieved here. There is high input impedance, low output impedance, and all the merits can be achieved. So such type of RC coupled amplifiers are used in public address systems, tape recorders, record players, and in stereo amplifiers. The next circuit is about the emitter follower circuit where you could see again voltage source with a transistor. But the only thing is here the resistance which is connected in the collector part of the transistor is missing. So when RC is reduced to 0, the output is taken from the emitter terminal instead of collector terminal. So what is the effective input voltage? All the V0 will be added with Vs. So Vs minus V0 is the resultant voltage. Since all the output voltage is added with the Vs, the gain will be drastically reduced because V0 is with a negative sign, and the gain will also be less than unity. For example, if 1 volt is given from here, the output voltage will be equal to 0.8 volt. So 0.8 divided by 1 will be equal to 0.8. That is, in case of emitter follower, the gain of the amplifier will be less than unity. And such circuits are used for impedance matching. Why it is impedance matching circuits? Because since there is no resistance, the output impedance is quite low. Since because of the negative feedback, here the input impedance becomes very high. So input impedance is high and the output impedance is low. Such circuits can be used for impedance matching circuits. And this type of emitter follower circuit is used in the last stage of the signal generator. Another main advantage of this circuit is it works as a buffer amplifier. How? Because of its high impedance and low output impedance properties, emitter follower is capable of giving the power to the load because there is no any resistance here in the output part. So whatever voltage which is developed across the collector can be delivered to the load which is connected at the output terminals without any requirement of the input voltage. So the output will be delivered without any problem or without any requirement of the input signal. So such amplifiers are called as a buffer amplifiers. And how this works? If the voltage source, that is Vs, increases, this voltage will also increases, output will also be the same as that of the input voltage. When we take the output across the emitter, the output will be same as that in the input. So the emitter is following the input voltage, and hence the name comes as the emitter follower circuits. So to summarize all the topics related with the negative feedback amplifiers, we started with the feedback, types of feedback, and we discussed about the voltage gain, and we discussed about the advantages, and we end up with the two illustrative circuits where we can make use of the negative feedback. And to conclude, though the gain of the negative feedback is low, it finds advantage over the many electronic circuits because of high input impedance and low output impedance. And these are the few references where we can tap the information related with this negative feedback. And for any further clarifications, feel free to comment us, query, to post any queries in the Google Classroom for which the class code is given. And don't hesitate to mail us if you have any queries. And stay healthy. Let us all meet again in the next module. Thank you.